Acceleration due to gravity. Acceleration due to gravity means when a body is falling freely from certain height due to the gravitational attraction, that body increases its velocity from the starting point to the whenever it reaches to the ground. Due to that, change in velocity is a acceleration. Due to the gravitational attraction, the acceleration of a freely falling body due to gravitational attraction is called acceleration due to gravity. Means when a body is falling freely from certain height, when a body is falling freely from certain height due to the gravitational effect, gravitational attraction, that is called acceleration. In that situation, the body possesses acceleration. Velocity is increased. So that's why that acceleration is called acceleration due to gravity. Means acceleration due to the gravitational attraction, the velocity is increasing whenever the body is falling freely from certain height. So that's why it is called as acceleration due to gravity, and it is denoted with the small g, and its value will be in centimeters CGS 980 centimeter per second square, and as well as in meter per second 9.8 meter per second square. In feet we can write that is 32 feet per second square. 32 feet per second square. These are all the values of acceleration due to gravity. Whenever the body is falling freely, it increases its velocity, means it possesses acceleration. Whenever the body is falling from certain height, the acceleration due to the gravitational attraction, the acceleration of a freely falling body due to the gravitational attraction is called acceleration due to gravity. In case of, we have derived the equations of motion. In equations of motion, these are when the body is falling freely from certain, body is in motion from certain height, it is moving vertically downwards due to the gravitational due to the gravitational attraction of earth, then that fall is called as a free fall. Whenever the body is moving from certain height due to the gravitational attraction, that fall is called as a free fall. Due to that one, the acceleration will be for freely fall, acceleration due to gravity will be positive, because of it is under the gravitational effect the body is acting. So that's why it is having that some of the velocity is adding due to the gravitational attraction, that body possesses the g is equal to 9.8 meter per second square, plus the additional velocity will be added to that one. So that's why it is a is equal to plus g, acceleration due to gravity whenever the body is freely falling, that is will be positive. In case of equations of motion for freely falling bodies, we know that what is the equations of motion. V is equal to u plus at, and the second one is s is equal to ut plus half at square, and the third one is v square minus u square is equal to 2as. These are the kinematical equations of motion. So that in the kinematical equations of motion, we are going to substitute whenever the body is freely falling, means it is from the certain height is having, and it is freely falling. So here it is that whenever it is falling from certain, if we consider that the height will be s, then s is equal to the displacement of a body will be s is equal to h, and it is under gravitational effect, the body is moving vertically downward. So that's why a is equal to plus g. Whenever it reaches to the ground, near to reach to the ground, the velocity possessed will be v. So here whenever the body is freely falling, its initial velocity somehow wherever it is started from rest. So that's why a is equal to 0, u is equal to 0. Listen, whenever the body is falling freely from certain height, that initial velocity will become 0 whenever it is freely falling, whenever it is releasing. Otherwise, if in case of somehow throw that thing, then a object is thrown by by using the force, there will be some velocity will be there. Whenever it is freely falling, whenever it is released, then it is freely falling, then only the initial velocity u is equal to 0, a is equal to plus g, and s is equal to h, and its final velocity will be v. So from that, the equations of motion, kinematical equations of motion will be changes. The fourth one is Sn is equal to u plus a of n minus 1 by 2. So these equations can be changed as that is S is equal to h, a is equal to plus g, and initial velocity u is equal to 0, and final velocity v is equal to v, means the final velocity considered as a v. So that's why we are substituting this equation. The first equation will be, that is v is equal to u plus at is changes as v is equal to v, that is equal to u is equal to 0 plus a is equal to plus g into t, means v is equal to gt be the equations of first equation of motion. And the second equation of motion will be s is equal to ut plus half at square. So s is equal to ut plus half at square. S is equal to ut plus half at square. If we substitute those values in this case, we can write that s is equal to, instead of s, h, that is u is equal to 0. So the total term becomes 0. 0 into t, 0. Then half, instead of a is equal to plus g we have. So that's why g t square, that means h is equal to half gt square. So this is the second equation of motion. In case of third equation of motion, v square minus u square is equal to 2as. V square minus u square is equal to 2as means v is equal to, we have that is v square minus 0 square, that is equal to 2g, s is equal to h, a is equal to g, s is equal to h. From that equation we can write that v square is equal to 2gh, and also this is one of the equation, and also we can write that v is equal to root 2gh, also we can write. These two equations can be write from the v square minus u square is equal to 2as. The last one is the fourth equation can be changes as Sn is equal to u plus a of n minus 1 by 2 can be changed as Hn is equal to u is equal to 0. So that's why a is equal to g of n minus 1 by 2. This is the, by substituting the values we can, these are the equations whenever the body is freely falling from certain height, equations of motion for a freely falling body. Then if in case of the body is projected vertically upwards, means equations of motion for a vertically projected body, whenever the body is projected vertically upwards, then here let's see, whenever the body is projected vertically upwards, it consists of some initial velocity, that is s, and it did not reach the maximum height. So that's why there is a final velocity is also there. It is before reaching the maximum height. Before, whenever the body is projected vertically upwards, means initial velocity is there and it is under motion, then it is having the final velocity is also there. It didn't reach the maximum height, so only it reached possess the final velocity will be there, and s is equal to h. When the body is projected vertically upwards, which is the opposite direction to the gravitational attraction, means the acceleration due to gravity will be negative, which is moving more than the gravitation. If the body is acting on the gravitational effect acting on the body, above that, beyond that, the body is moving opposite direction to the gravitational attraction. So that's why here the a will be, acceleration due to gravity will be minus g. Acceleration due to gravity will be minus g. Here initial velocity is there, final velocity is there, the displacement will be s is equal to h, distance travelled by a body, and acceleration due to gravity will be a is equal to minus g whenever the body is projected vertically upwards. It is not making an angle, either moving the vertically upwards or downwards. Along the straight line it has to move in the along the x axis or along the y axis. It has to move in the single direction along the straight line. Whenever they are moving the straight line, then only equations of motion can be written as. If in case of if the body is changes its direction whenever it is in the air, or here also we are ignoring the air resistance. We are ignoring the air resistance. If in case of the air resistance can be considered, then we can get the another equations. We are ignoring the air resistance here. So then only in the freely falling body case also, in the vertical upward body case also, we are not considering the air resistance. So here it is that A is equal to the first equation of motion, V is equal to U plus AT. That can be V is equal to, we have velocity, V is equal to, U is equal to velocity, we have A is equal to minus G into T. This is the first equation of motion whenever the body is projected vertically upwards. And the second one is S is equal to UT plus half AT square. UT plus half AT square be the second equation of motion. So by substituting this, S is equal to H we have, A is equal to G we have, and U is equal to U is there, V is equal to V. Velocities didn't change because of whenever the body is projected, it is having initial velocity as well as it have final velocity also. So S is equal to UT plus half AT square. We are substituting, instead of S is equal to H we have, so H is equal to UT plus half. Instead of A we have that minus G into T square. So H is equal to UT minus half GT square. This is the equation for second equation of motion for vertically projected body. And the third equation will be V square minus U square is equal to 2AS. V square minus U square is equal to 2AS. Then we can get that V square minus U square is equal to minus 2GH. Minus 2GH. These are the equation for the velocity displacement relation. V square minus U square is equal to minus 2GH. If in case of the body, whenever they reach to the maximum height, at maximum height the velocity becomes 0 but not acceleration. So here it is that whenever the final velocity becomes 0, then only we can get that U is equal to root 2GH. That is the furtherly we will discuss in the parameters of a body. So here it is the third equation. Then the last one is fourth is Sn is equal to U plus A of n minus 1 by 2 be the equation of motion. Then from that equation Hn is equal to, S is equal to H, we have U. A is equal to minus G of n minus 1 by 2. This is the equation of motion whenever the body is freely falling from certain height, or either the body is projected vertically upwards. Once again, when the body is falling from certain height due to the gravitational effect, that is called as the acceleration that body possesses, so that is called as the acceleration due to gravity. Means the acceleration of a freely falling body due to gravitational attraction is called acceleration due to gravity. It is denoted with a small g, and value of small g will be 980 centimeter per second square, or in case of meters 9.8 meter per second square. Feet will be 32 feet per second square. Then equation of motions, when the body is freely falling, motion of your body when from certain height, if it is moving under the gravitational attraction towards the ground, then that is called as a free fall. In that case of free fall, the acceleration due to gravity will be positive, means A is equal to plus G. So in that plus G, we have the equations of motion. 4 equations of motion is there. From that, by substituting, whenever the body is falling from certain height, its initial velocity becomes 0, U is equal to 0, and S is equal to the displacement distance travelled by a body, S is equal to H. From that, here in a straight line, displacement and distance both are the same, because of there is no change between the displacement and distance when the body is moving along a straight line in the same direction. Then A is equal to, it is moving under the gravitational effect, so that's why A is equal to plus G. We are substituting these two total values in the equations of motion. From that we can get that from the first equation of motion will be at V is equal to GT by substituting the values. From S is equal to UT plus half AT square, we can get the U is equal to 0, so total term becomes 0, that is H is equal to half GT square. And the thing is V square minus U square is equal to 2S. From this relation V square is equal to 2GH, or V is equal to root 2GH also we can write. And for fourth one is Sn is equal to u plus a of n minus 1 by 2 be the nth second distance travelled by a body in nth second, that is Hn is equal to g of n minus 1 by 2 because of u is equal to 0 and a is equal to plus g. So g of n minus 1 by 2. And in case of if the body is projected vertically upwards, it didn't reach the destiny, means the body didn't reach the maximum height, only it is projected vertically upwards. So here it is that whenever the body is reached to this, here is also we can write that it is having velocity, it did reach to the ground. Here is also same thing, it didn't reach to the maximum height, did not reach to the maximum height. So that's why whenever the body is falling, moving vertically upwards, projected vertically upwards, then its acceleration due to gravity is moving opposite to the gravitational attraction, opposite direction to the attraction, gravitational attraction. So that's why acceleration due to gravity will be a is equal to minus g. So s is equal to h, then initial velocity is there and final velocity is also there. By substituting these values in the kinematical equations of motion, then we can get v is equal to u, a is equal to minus d is there. So that's why minus g, u minus gt is the first equation of motion. And then the second one is h, s is equal to h, we have ut means ut and of gt square means of at square means plus by a is equal to minus g is there. Whenever we multiply this one, then h is equal to ut minus of gt square. Then in case of the third equation of motion, that is v square minus u square is equal to 2as, by substituting v square minus u square is equal to a is equal to minus g is there. So that's why we can get that minus 2gh. The fourth equation will be Sn is equal to u plus a of n minus 1 by 2 there. So Hn is equal to u minus of g into n minus 1 because of a is equal to minus g when the body is projected vertically upwards. This is about when the change of equation of motion, change of equations of motion when the body is freely falling and projected vertically moving upwards. These are the changes of equations. By using these equations, we can find out the parameters. What are the parameters which are involved by the body during its motion, means whenever the body vertically projected upwards, then what are the parameters which is involved, we can read now.